Assalamu alaikum students. Lastly, we have read about the differential coefficient of sin x as well as cos x by ab initio. Now, today we are not going to solve it by ab initio, but we have to remember as we are having the basic six trigonometric ratios. We have to now remember their differentiation or their differential coefficients. So, differential coefficients of trigonometric functions. For example, if we were having y equals to what sin x, then we were having d by dx of sin x, the first function, that comes out to be what, cos of x. Or similarly, if we y having to be as cos x, what we calculated that d by dx of cos of x equals to what, minus sine of x. Likewise, y equals to, now we will take tan of x, tangent of x, then d by dx of, we are not going to derive this by ab initio, but now we have to remember, because we are going to read that part of the calculus which is important in physics. Otherwise, in once person opting for maths, there he has to go through it in first principle also. So now d by dx of tan x, that comes out to be tan of x, that comes out to be sec square x. Similarly, we can have y equals to what, cot x. Then we have to remember d by dx of cot of x equals to what, minus cosec square x. Likewise, y equals to sec x. Then we are having d by dx of sec x equals to what, sec x tan x. Or we can have likewise many more, one more, that is y is equal to what, cosec x. So d by dx of cosec of x, cosec x equals to what, minus cosec x into cot of x. So this was all about what we have to, now we have to remember them. D by dx of sin x, cos x, d by dx of cos x minus sin x, d by dx of tan x, sec square x, d by dx of cot x minus cosec square x, d by dx of sec x tan x, d by dx of cosec x minus cosec into cot. So we have to remember them. Now we can have some questions related to it, which we are going to solve them. Likewise, if we are having y equals to sine of 2x, first you have to remember, if we are having a function like this, y equals to sine of u, then its differentiation according to formula d by dx of sine of u, because it's x here, it is u here, sine of u, it is x here, it is u. First in the case it was here sin x, it was simply cos x, but now it is d by dx of sine of u. It will be sine of anything, that will be the cos of that thing, cos of u, into it will be d by dx of u. Now we have to differentiate u, where u is function of x, function of x, and you have to remember that differentiation of constant is 0. D by dx of some constant, any constant, that comes out to be 0, because we say differentiation is change in the, once we are going to be change in the independent variable, then there is change in the dependent variable. How much change comes in the dependent variable, that's called as differentiation. But once we are having a constant, constant is not varying at all, so the differentiation is simply 0. Let us have a simple question here. Let we have to differentiate sine of x, y equals to sine of 2x. We are not going to solve it by now ab initio, we are going to directly use now formula. So dy by dx equals to d by dx of, instead of y we will place sine of 2x, but we know sine of anything is cos of that thing, it will be cos of 2x. Had it been only here x, then it was, the answer was simply cos of x, but here it is also 2x, then we have to write it down d by dx of 2x. We have to go uh, for the differentiation till we reach the x. Now the answer will be simply cos of 2x into simply 2. Then this 2 is not multiplied here because it's theta, it comes out with 2 cos of 2x. This is the answer. This is the answer which you have to remember.